Hello, and welcome back to the Anagame series. In this video, we will explore the Anaface library, which is responsible for providing widgets and a means to interact with them. The main widget is called the TControl, and is the root class for most all of the widgets in the library. It supplies functionality such as location management, text, borders, and content. Location is managed via a location rectangle. Earlier there was also a snip rectangle in order to support scrolling, but it has since been replaced by use of Direct2D's layers in the draw method. The border is managed by special border objects. The content, which can hold a T bitmap brush for drawing images, is managed by content objects. Text, which currently manages DirectWrite directly, handles text. Later in this video, I'll explain why there are 3 such objects for each component. For now, I want to briefly go over some of the other widgets that extend the TControl, as well as one that doesn't. T-Layout allows you to organize child controls in a stack, gallery, or grid. T-Layout X allows you to add or remove rows after creation. T-Spreadsheet is intended to offer Excel functionality. It needs work. Gadget-based controls, of which there are currently 5 of them, extend T-Gadget Control. T-Radio Button and T-Combo Box are self-explanatory. T-Text Control offers editing capabilities to text and includes support for number boxes, passwords, and password peek. Text Control is also the base class for the T-Prompt Control, which offers a terminal-like interface. T-Databind supports basic data binding in a manner similar to T-Layout stacks. T-Tree Databind takes in a T-Object node and draws the contents of all the nodes currently accessible to the T-Tree Databind control. T-Flyout currently extends T-Layout, though this is being changed via the Flyouts branch, where it is separate from T-Control and can be used to draw last. T-Context menu is intended to extend T-Flyout. The final major category of controls are functional controls. Anaface UI holds a series of controls, but only draws one at a time. T-Arena holds a T-Arena engine from the video graphics library, and also acts as a de facto camera for said arena, and thus also holds direction, location, and up data. T-Image is intended to add image editing capabilities to the T-Control. T-Scroll Control is a control dedicated to scrolling one child control. T-Databind and T-Tree Databind will attempt to insert a scroller control between it and its parents if they detect their contents overflowing their assigned drawing space. Right now, regular T-controls hold resources for scrolling, though I'm on the fence over whether those resources should exclusively be moved to the T-Scroller control. Scrolling is also supported by T-Scroll bars, which are not T-controls, but help with scrolling functionality. When setting up an Anaface, the main mechanism is to use the Anaface parser class, which taps pages do. If you ever see fit to add a new type of control to the Anaface library, you'll also want to update the Anaface parser class, chiefly its obj method. The parser and reader will go through the TML file. The first control detected will be the root control. Note that there can only be one root control. Subsequent controls will be added to the control tree based off of the number of dashes for said control in TML. Once the parser and reader are finished constructing the tree, control is returned to the page, which then calls the root control's onCreate method. It is here that the controls learn what drawing space is available to them, and they set their locations accordingly. They also have a series of attributes stored in their attributes attribute, and during the run of the onCreate method, they are used to actually create the control, border, content, text, etc. T-controls also provide an interface for responding to Windows messages. The tap library intercepts these messages and sends the relevant information to the root control, which then either returns or sends the message down to one of its children. Many controls can have special events that are activated when certain messages are met. For instance, Suppose a certain control has some sort of event for when the user clicks the left mouse button while hovered over it. It can then set the contents of an event args structure it holds. It will also add an event ID cred object to a tData array provided by the method call so that the tap library will respond to this event. These controls can also change contents based off of whether the mouse is hovering over the control or clicking on the control. This is where the multiple text border content objects come in. Possible information currently supplied by the event ID cred include the event type, pointed to the control that raised the event, reference to a scroll bar in case the event involves a scroll bar being clicked or dragged, and a flyout if the event requires the window to draw a structure over the rest of the content. I'll go into greater detail on the message to event conversion in a later video, after I cover the tap library. I'll also cover animations in a later video, since while I could cover them here, knowledge of the tap library would help in understanding animations as well. I hope you can join me in the next video, which involves an overview of the tap library.